So we're all trying to build smarter systems, right? Things like AI agents, real-time dashboards, you name it. And at the heart of any intelligent system is memory. But let's be real, getting memory right is usually a complete mess. Today, we're going to unpack a really powerful design pattern that's all about bringing some sanity back to that chaos.
And that brings me to a question that I bet hits home for a lot of you. Why is it that our systems, for all their power, still feel so forgetful? Why is managing their context, what they know at any given moment, so incredibly chaotic? It's a super common, super frustrating problem, and it pushes us into building these brittle, one-off solutions that break all the time. And usually we end up going down one of two dead-end roads. On one side, you've got the per request assembly method. This is where you fetch and join absolutely everything from scratch every single time. It's thorough, but it's also painfully slow, and the costs just skyrocket. On the other side, you've got the simple static cache. You just kind of stuff a blob of data somewhere and set a timer, hoping it's still good in 5 minutes. It's faster for sure, but you're constantly dealing with stale data, bad decisions, and those dreaded invalidation storms, where everything tries to refresh at once and the whole system just grinds to a halt. And all of this chaos creates these huge operational headaches, right? Freshness is a joke. Your systems are making calls based on old, outdated information. Explainability, forget about it. Trying to figure out why the system made a certain decision is a complete nightmare, especially when you need to for compliance or just debugging. Your costs are out of control, scaling with traffic instead of when data actually changes, and your velocity just tanks because every new feature feels like you have to build a whole new, fragile data pipeline from the ground up. It's not sustainable.
Okay, so what's the way out? We have to move past these ad hoc hacks and start using a formal pattern. And that pattern has a name. Reactive Composite Memory, or RCM for short. It's a blueprint for bringing order, governance, and just plain sanity to how our systems remember things. So what is RCM really? Well, first off, it's not a product you can buy. It's a design pattern, a way of thinking. And the core idea is to stop treating memory like a static bucket you have to constantly query. Instead, you think of it as a live, reactive data flow. Raw data flows in from all your sources, it gets composed together into useful context, and the result is a versioned, unchangeable snapshot we call a frame. And here's the magic part. These frames update themselves automatically whenever any of their source data changes. It all starts with something called source signals. Just think of these as the raw, time-stamped facts that feed your system. This could be anything. A stream of events, changes coming out of a database, a new file landing in storage, updates from an API. You get the idea. These signals are the ground truth for everything that comes next.
Now, once you have your ingredients, the source signals, you need a recipe, and that's where context views come in. A view is basically a declarative plan. It's a recipe that says, take this source, join it with that source, filter it this way, and aggregate it that way. This is really the brains of the whole operation. It's where you define the logic for what your system actually needs to know.
And what do you get when you follow that recipe? You get a frame. A frame is the final output, the finished dish. It's an immutable version snapshot of the context at a specific point in time. And here's the really cool part. Every single frame comes with its own birth certificate. It knows exactly which sources, which recipe, and which time window created it. This makes your system's memory perfectly auditable right from the very beginning. So, to really get this, let's break RCM down into its two main pillars. The first one is its composite nature. And honestly, the best way to think about this is like building with Legos. You take simple, standard blocks and you snap them together to create something amazing and complex.
And that's exactly how views are designed to work. You don't build one giant, monolithic, impossible to understand query. No way. Instead, a really sophisticated view is almost always built by composing several smaller, simpler, and reusable views. You're building bigger Lego creations out of smaller Lego pieces.
And this slide is a perfect example. Let's walk through it. We start with a few simple, reusable base views. First, we have a document view for the user profile, maybe pulling from a database. Next, a table view that shows recent activity, coming from an event stream. Then, maybe a series view that tracks KB fixes over time from a knowledge base. See how they're all different shapes and sizes? Each one is useful on its own. But the real power comes in step 4, where we create a composite view that joins all three of them into a single rich support context. This becomes a live, dynamic dashboard for a support agent, giving them everything they need all in one place.
And the benefits of this are they're huge. That little user profile view, it can now be reused in dozens of other contexts by different teams all across the company. You get so much clarity because you're breaking down complex logic into small, understandable, testable parts. And most importantly, you get velocity. Your developers can ship faster because creating a new context is now about snapping existing Lego blocks together, not building a whole new pipeline from scratch every single time.
Okay, so we've got this powerful composable memory built out of Legos. But how does it stay fresh? How does it stay up to date? Well, that brings us to the second pillar, reactivity. This is what makes the memory feel alive. So here's the fundamental shift. With RCM, you don't pull. You don't have services constantly knocking on the door asking, hey, anything new yet? Anything new yet? Instead, the system reacts. When a change happens way back at the source, that change automatically flows through the entire system, all the way to the end consumer. It's a push model, not a pull model. And that changes everything. And here's what that looks like in practice. Let's say a new event arrives. A customer files a new support ticket. Instantly, the system identifies every single view that depends on that source data. It then automatically recomputes just those affected views, creating a brand new versioned frame with the updated context. And finally, that fresh frame is delivered to all the subscribed consumers, the agent's UI, another backend service, whatever. It's this seamless, automatic cascade of updates. So when you put these two pillars together, the composite Lego-like structure and the reactive data flow, you get this huge payoff. You really do move from that chaos we talked about at the beginning to a system that is fundamentally under your control. The first massive payoff is explainability. That dreaded question, why on earth did the system do that, finally gets a real, concrete, verifiable answer. Every decision becomes auditable by its very construction. And that's all thanks to the rich metadata that's baked right into every frame's header. It's got the exact source data that was used, a unique hash of the logic plan that built it, and the precise time window that it represents. This isn't just some messy log file. It is a machine-readable audit trail. It means you can perfectly replay what the system knew at any given moment in time. The second big win is on the economic side of things. Remember those out-of-control traffic-based costs we were talking about? With RCM, your costs finally become visible, predictable, and controllable. RCM completely flips the cost model on its head. You compute when data changes, not when somebody asks for it. That one computation then serves hundreds, maybe thousands of consumers, which means you're amortizing the cost and eliminating all of that redundant work. And because it's a formal pattern, you can actually build governance right in, things like budgets, quotas, and rate limits, to make sure no single context accidentally bankrupts you. And finally, that vague, fuzzy concept of data freshness stops being a feeling and it becomes a hard, measurable metric. It's something you can actually manage with real engineering discipline. And this is done using a concept from stream processing called watermarks. You can think of a watermark as a little timestamp that's embedded in the data stream itself, which tells the system how up to date it is. This lets you set and monitor concrete service level objectives, or SLOs, for freshness. You can actually say the 95th percentile of our data lag must be less than 2 seconds. And if the system gets overloaded, it can gracefully degrade by slowing down updates just enough to meet that SLO, instead of just crashing and burning. So I'll just leave you with this thought. RCM is a really powerful pattern for taming the chaos of system memory. So if your systems could remember things perfectly, if they could react instantly to new information, and if they could explain themselves clearly, what new kinds of amazing, intelligent applications could you build?